I'm going to do one more two-wire problem where we're finding the magnetic field, except this time our perspective has changed, okay? I know, it's going to be exciting, okay? That this time, rather than wires like this, we're going to have wires like this, okay? Where they're literally, the wire is coming this way, or the wire is going this way. In this case, because they're two dots, remember a dot represents an arrow that's being shot towards you, the positive Z direction, that these are two dots so that my wire is going like this and the current is flowing this way. So we are, in this problem, we're trying to find our net magnetic field right in between them. So if we were to do this, you would use your right hand. I know, you know, you have to use your right hand. See, I am super lucky. You want to know why I'm super lucky? See, I write with my left hand. So I can do the right hand rule, okay, and write at the same time. It's amazing how lucky I am. Now, if you are unfortunate and you have to write with your right hand, I'm really sorry. I mean, blame your parents. But you are going to have to put your pen down, do the right hand rule, pick your pen back up, and then answer the question. I know you're going to waste precious seconds, okay? But you do need to use your right hand. It's called the right hand rule because you have to use your right hand, okay? All right, so I have for the red wire here, my current is coming out of the page. Now remember, we're not going to make a fist. We're curling our hand. So if you look, well, look how this is going to curl around. Oh yeah, it's going to go around like this. So I'm going to draw an arrow showing the magnetic field as it goes around. It's going to go this way, and then this way, and then this way, and this way. And how do I know that? How do I know that? Because I used my right hand rule. Now, in this particular problem, where am I asking you to find the magnetic field? Right there. Well, right there, which way does the magnetic field point? Oh yeah. So from the red wire, I'm just going to draw a little FPD at the bottom here. It's going to point directly up. So right there, my magnetic field is going to point directly up. Actually, you know what? So we don't get confused, I'm actually going to just draw a red arrow pointing straight up right there, okay, from the red wire, okay? All right, everybody got it so far, so good? Okay. Now if we want to do the blue wire, well, the blue wire also has a magnetic field that is circular going around it. So that the blue wire is also going to look, it's going to point in this counterclockwise direction as it goes around. But in the center, the blue wire actually points down. So if you look, the red wire, the magnetic field is pointing, oh shoot, sorry, I said down. We're not going to say that. The red wire points to the top of the page, and the blue wire points to the bottom of the page. Red wire, positive Y, blue one, negative Y direction. Is everybody okay with that? Well, to find my net, what am I going to have to do? Yeah, subtract. That's right. Okay. Yeah, you're going to have to subtract. Just be careful. Do you always subtract? No, of course not. In this case, you subtract because they're pointing opposite ways. Okay? Then you're going to use your two equations. So for the blue one, for the red one, it's going to be B equals 4 pi times 10 to the minus 7 times 2 divided by 2 pi times 0.1. And then you can solve. And then for the other one, it would be 4 pi times 10 to the minus 7th times 5 over 2 pi, also 0.1, and then you can solve. Okay. Then I'm going to let you guys actually solve, but you're going to solve this, you're going to solve this, you're going to add them together, get your net. Remember, bigger minus smaller, so our final direction is either going to be to the top of the page or to the bottom of the page. If you're smart about it, you can already think, well, geez, wait a second. I'm the same distance away. This has more current, so the magnetic field from this one has to be bigger. Oh, yeah. So you better get to the bottom of the page for your final direction, okay? Hopefully you should be able to solve that no problem. If I ask you where is because I do, where is the net magnetic field going to be 0? Well, maybe it could be 0 in there, right? But let's check over here. Over here, my blue one would also point that way. Does everybody see? So the blue magnetic field, loop around. Oh yeah, that's never gonna be 0. Okay, or over here, my red one is also gonna point this way. So over here, it can never be equal to 0, so it has to be in between. So then, just like we did in our last problem, you're gonna wanna call, this some random distance d, and then this distance would be 0.2 minus d, and then you're gonna say this magnetic field equals this magnetic field, and you're gonna solve. I'm not gonna do that because I don't want to ruin your fun. Okay, so make sure you all do that, and that should be good. All right, bye, kids.